So for those people who didn't like the idea that domains could be leaked, there was another idea called NSEC3 to try and prevent domain enumeration, where someone can just learn all of the domains, maybe learn that there's a secrets.google.com or a competitors.google.com or some other top secret company thing. So the defense is to redesign NSEC. This is now NSEC3. It's a newer version of NSEC that some name servers use and some don't. And the idea here is to actually hash all of the domain names before putting them in alphabetical order and forming ranges. So think about what NSEC did, the original version. We would take all of the domains that exist, we would list them out, and then we would identify ranges in between every single pair of existing domains. That was the original design. In the NSEC3 design, we're doing the exact same thing. The only difference is that we hash everything before forming alphabetical ranges. So if we have 5 different domain names, we first hash all 5 of them. That creates 5 different hashes. And then we arrange the hashes in alphabetical order. They might change in terms of their relative order, but that's fine. You take the 5 hashes, you put them in alphabetical order, and you sign the ranges in between hashes. That's a possible idea. So maybe Google has 2 subdomains in this picture. We hash one of them, it comes out to C6 something something. We hash the other one, it comes out to D8 something something. What they were originally doesn't even matter. But now we know that something hashes to C6 and something hashes to D8. Those are the 2 domains that exist, and they hash to these 2 numbers. Now we can sign ranges just like we were doing before. We can say there's nothing between C6 and D8 in the hashed world. In other words, if you take your domain, whatever it is, nonexistent.google.com, something else, if you take your non-existent domain and you hash it, and you find that it's in between C6 and D8, it doesn't exist. And this is the record that proves that there's nothing between C6 and D8 in the hashed world where I alphabetize all the hashes. And I can sign a second record that says there's nothing between D8 and C6, wrapping around as needed. So the ordering of domains might no longer be the same, but it doesn't matter. We're just doing this in the world of hashes and saying, if you hash your domain and it falls between C6 and D8, it doesn't exist. That's the idea behind NSEC3. It's the same thing. You're just applying a hash beforehand to try and stop domain enumeration. So can we stop at NSEC3? Is that good enough? Once again, it depends on your threat model and how you feel about the domain enumeration attack. Some people might say hashes are good, but they don't stop brute force attacks. If an attacker learns that C6 is a valid hash and D8 is a valid hash, they can try and brute force through a dictionary and learn the domain name anyway. So that's one possible counter argument, that they can brute force and learn the domain name and figure out what the original value was that hashed to C6 or D8. This is more possible if you're using domain names that are easy to remember. So think about your average domain name. It's usually something like maps.google.com or images.google.com. Those are pretty short, understandable names. So somebody brute forcing all of those words has a pretty good chance of learning your domain name anyway. To defend against that, you'd have to use long, random domain names. So your subdomain would have to be something like c529.google.com. Maybe that makes it harder. But again, whether you even need to stop domain enumeration is up for debate. So it's an open question whether this defense is even needed, but it does exist if your name server is paranoid and wants to stop domain enumeration or make it harder. To really stop enumeration, you just cannot give attackers even a hash of what the domain name is. So you'd have to fall back to online signature generation, where you generate the signature on demand. That's, at least as far as we know, the only way to prevent enumeration entirely.